Yeah, good morning. So in the last lecture, we have covered the part of the sand of unit number 1. So in our advanced concrete technology subject. So the next part of this unit number 1 is the aggregate. So as we have discussed a lot of times, the ingredients of concretes are cement, sand, and aggregate. So the aggregates are maybe fine aggregate, coarse aggregate. So the fine aggregate is nothing but sand, and coarse aggregates are the 10 mm, 12 mm, or 20 mm, which we are using in the concrete. So the cement and sand part we have covered. So the last part of this unit is the aggregates. So what are the aggregates and what are the various tests we have to conduct for the aggregate and their sizes, why aggregate we are using in the concretes? So that we will study in this particular point. So what is aggregate moisture? So generally what is aggregate that we have to see first. The aggregates are the coarser content which we are using in the concrete mix to get the strength of the concrete. So the sum of while we are using concrete at the making concrete, and aggregates are we are using into the concrete, at that time some in the sum of the percentage the moisture is present in the aggregate. So the moisture content in an aggregate when batched into the concrete mixer is an important consideration. Why? So we have to consider, we have to make into the consideration the moisture content in aggregate while mixing into the concrete. So the aggregate particles have internal pores that absorb the water. So sometimes the aggregate having some small holes, or pores, so that the water get absorbed into that aggregates. Then the aggregate stored a stockpiles or bin is typically in well condition. Also, it contains absorb the water and moisture coating the surface. So the water is absorbed in some of the percentage, so that the surface of aggregate is coated with the moisture. The moisture is nothing but some of the in fine or small scale water is on the surface of the your aggregate. So that is nothing but the moisture. So that we are calling as a pre or surface moisture on the aggregate surface. So then the total moisture content in the aggregate is some of the absorbed moisture and free surface moisture. So the total moisture content as a absorbed moisture and free surface moisture. It means if holes are there, the water may be absorbed, and if holes are not there, still this on the surface of the aggregate, some of the in some of the percentage the moisture are present on the surface. So then actually the aggregate contains the four states. So when the aggregate has no moisture on the surface or the interior pore, then the aggregate is a dry. When we call as aggregate is a dry, when the aggregate has no moisture on the surface. जर surface वरती जर काही moisture नसेल तर आपण त्याला dry aggregate असं म्हणतो. Then when the some interior pores of the aggregates are filled with water and there is a no moisture on the surface of the aggregate, is in the air dry state. So first is a dry state, it means no aggregate on surface. Second is a somewhat air holes are filled by the waters. Holes to the aggregates are there, and that aggregates, that holes filled by the water. So that condition we are calling as a air dry state. So four states are there. So first is the dry state, second is the air dry state, third is the when the interior pores of the aggregates are filled with water, but there is no moisture on the surface of the aggregate. So that condition is the saturated surface dry aggregate. It means state. It means what? Where interior pores of aggregate are filled with water, but there is no moisture on the surface, then aggregate is in the saturated surface dry state. And the fourth state of the moisture content is when all the interior pores of the aggregate filled with water, there is no moisture on the surface aggregate and is in the wet state. म्हणजे aggregate तुम्हाला ओला दिसत असेल, खडी जी कॉन्क्रीट मध्ये वापरतो ही जर ओली दिसत असेल तर इट मीन्स व्हॉट? No surface water is present on the surface, but the air gap holes are covered or filled by the water. So this is the state we called as a wet state, and at that time we have to keep the aggregate into the oven. So here written the dry oven and SSD condition are typically found for the aggregate in storage. ज्यावेळी आपण ऍग्रीगेट स्टोअर करतो त्यावेळी असं पूर्णपणे पसरून ठेवतो का? नाहीये. इट मीन्स व्हॉट वी आर डुईंग, वी आर कीपिंग इन अ ह्यूज quantity. So internally there may be a water surface, in the water is present on the surface of the aggregate. So this is the condition of aggregates. Then so then here that conditions shown in the graphically. So dry state is shown in first sketch. Second stage is air dry aggregate is shown. It means that black dot indicates what? Holes to the aggregates are there. Aggregate ला holes आहेत आणि त्याच्यामध्ये काय होतंय तर water store होऊन बसते तुमचं. So then third sketch you can see the saturated surface dry aggregate. It means absorb water. Here water is absorbed. And in the fourth stage wet aggregate, so totally wet. So in the holes also aggregate is present and on the surface also aggregate is present. So these are the four states of aggregates which the water is absorbed, water is not absorbed, water is on the surface, and totally dry aggregate like this. So the bulk density of aggregate is very important while we are mixing the concrete and we are adding the aggregates into the concrete. So so bulk density of aggregate. The bulk density or unit weight of the aggregate is defined as the mass of the aggregate per unit volume. How we can define the aggregate? We can define that is the mass of the aggregate per unit volume is known as the bulk density of the aggregate. So bulk density is nothing but mass of the aggregate per unit volume. So the unit is expressed in kg per liter. So what factors affect the bulk density of aggregate? So the factors affecting on bulk density of aggregate are how densely the aggregate are packed, particle size and shape, the grading of aggregate, moisture content of aggregate, and the shape of the particles affects the closeness of the packing. So these are the factors affects the density of the aggregate. That density we are calling as a bulk density. So what is the procedure to find the bulk density of the aggregate? So there is a procedure to find the bulk density of aggregate. So the measure the volume of the cylindrical metal measure by pouring water into the metal measured and record the volume phi in liter. So what we have to do first while measuring the bulk density of the aggregate? So measure the volume of cylindrical metal. So cylindrical metal we have to use for the measuring the bulk density. So measure by pouring water into the metal measured and record the volume. So how much volume of that porous cylindrical metal is there, that we have to measure in liter. Then fill the cylindrical measure to overflow by means of shovel and scoops, that the aggregate being discharged from the height of exceeding 5 centimeter above the top. So we have to fill that particular cylinder with the aggregates in the step number 2. Then level and top surface of aggregate in metal measure with the straight edge or tamping bar. So we have to tamping that particular aggregate into that cylindrical metal, and then determine the weight of the aggregate in measure record, that is the W. So after filling that aggregate into the cylinder, we have to measure the weight. So that weight, measured weight, is in kg, and the volume of that particular cylinder is a V. So W by V, weight is a W and V is the volume. So W by V if we divide the volume to the W, then we will get loose unit weight or bulk density of the aggregate. So here W is the weight or loose aggregate in the cylindrical measure, and the volume of cylindrical measure in liter, so that the W by V will get the loose bulk density. So the calculation of voids that we have to measure in that bulk density. So here the percentage of voids is calculated by using this particular formula, G specific gravity minus gamma divided by G into 100. So where G is the specific gravity of aggregate divided by bulk density in kg per liter. So we can calculate the voids present into that particular cylinder. So what is the procedure for compacted bulk density? So we have calculated loose bulk density. Now we have calculated loose bulk density. It means in the cylinder we have filled a aggregate in loose state. But now we have to calculate the compacted bulk density. So how compacted bulk density we have to calculate? So again, same procedure will be there. Just we have to compact by using the tamping bar for 25 strokes. So if you see here procedure, again, measure the volume of cylindrical metal, which measure the pouring water into the metal and record the volume fee. Similarly, the cylinder is there, so measure the cylinder volume of cylinder in liter initial state. Then fill the cylindrical metal about the 1/3 full of the mixed aggregate and tamp it 25 times using tamping bar. Now open cylinder is there, we have to fill the 1/3 of aggregate and tamping the aggregate by 25 times. Again, another layer of the aggregate we have to fill into that cylinder, and again 25 strokes we have to give by the tamping rod. Again, finally fill the remaining part of the cylinder by aggregate, and we have to again tamp by using the tamping bar. Then remove the surplus aggregate using the tamping rod and straight edge. And again, then determine the weight of the aggregate and record the weight of the aggregate W in kg. So this is the procedure for the compacted aggregate. And then how to calculate, how to do the calculations. If you see the calculations for compacted bulk density is the compacted unit weight of the bulk density is equal or bulk density is equal to W by V. So W is the weight compacted aggregate in cylindrical measure in kg, and the V is the volume of cylindrical metal in liter. So W by V, we will get the compacted bulk density of the aggregate. So here again, we can calculate the voids present in the particular filled bucket. So the percentage of voids is equal to G minus gamma, specific gravity minus bulk density divided by specific gravity into 100. So we will get the percentage of voids present into that particular bucket. So now next test is on the concrete is the flakiness and elongation index of the aggregate. So this is the very important test of the aggregate. Why? Because the aggregates we are mixing into the concrete, but when we are making the concrete, so how much cover we are providing? I think you have learned the design of concrete structure. So you have designed this, I think, slab. You have designed a singly reinforced, doubly reinforced beam. You have designed. So how much cover we are providing? We are providing 20 mm, 30 mm cover to the steel. So if we provide the 20 mm, 30 mm cover to the steel, then how much size of aggregate minimum is required to cover that 20 or 30 mm space? Are you getting? If this is your beam is there and your rods are here, so you can see the sketch, whatever I am trying to draw. So if this beam is there and this is the your cover, effective cover, if we say 30 mm or 35 mm. So now the aggregates we are using, size of aggregate. So generally in the concrete, we are using aggregate maximum 20 mm for making the concrete. So 10 mm we are using, 12 mm and 20 mm. So maximum size of aggregate we are using as a 20 mm. So why we are using 20 mm? Because whatever the below part of this aggregate, below the steel in the beam, or if you see the slab, this particular slab is there. So in the particular slab, this like this steel is there. So below the slab, so if this is the slab is there, so below the slab also, so this cover is very less, 20 mm or 25 mm, 20 mm cover is there. So the aggregate should be passed below that particular rod. Whatever bars we have placed in X and Y direction in the slab, below that aggregate should pass. So that aggregate should pass below. So this aggregate size should be 20 mm. So elongation and flakiness, it means what? So what is the flakiness? Kiti लांब पाहिजे आणि किती जाड पाहिजे? That is the elongation and flakiness. The more elongation is also not allowed and more flakiness is also not allowed. So the flaky and elongated aggregates can adversely affect the concrete. जास्त लांब aggregate पण affect करतो concrete वरती आणि जास्त size असलेला aggregate सुद्धा affect करतो. So flaky and elongated aggregates are difficult to compact. So therefore, the flaky and elongated aggregates will reduce the concrete workability. See, the concrete workability they reduce and required more amount of water to produce the workable mix. So they reduce the workability and more amount of water is required to produce the workable mix. So proper mix, if we required, then the amount of water is more required. If we add the more amount of water into the concrete, then it will be the reduce the strength. Then increasing water content with reduce the concrete strength and durability. Also, if the elongation and flakiness is more, then the strength and durability of concrete also reduce the if we use the such aggregates into the concretes. And these aggregates are not robust which leads to lowering the concrete strength also. So if you see this sketch, if you see this sketch, so we have to pass these aggregates into this particular size of elongation. We have that instrument or apparatus that we have in our laboratory. So we have to pass the aggregates into this particular. So 63 mm to 50 mm size is there, 50 mm to 40 mm. So this greater size of aggregates we are using in the road side. 40 mm, 60 mm चे aggregates कुठे वापरतो आपण रोड वरती वापरतो. But in the concrete we are using up to the 20 mm. So here it given the size. So the aggregate should pass into specific size. The aggregates we are using for road, it should be passed from 40 to 50. So aggregates is required for waterbed macadam road At that time, aggregate should be above 50 mm size. So it pass should be 50 to 63. So like this, so if aggregate we have to use concrete, it should pass from 16 to 20. The aggregate should be 12.5 mm. It should pass from 12.5 to 16 mm. And aggregate below 10 mm or 10 mm size aggregate, it should pass from 10 to 12.5 mm. So likewise, the aggregates we are using for the specific type of construction, for making the concrete, for making the WBM road, for making the bituminous road. For that, this size of aggregates we have to decide properly. This is very, very important to decide the size of aggregate, because why these sizes we have elongation and flakiness we have keep into mind, because the depends on the size, our mixing of that particular layer is very important. If we mix the if we use the 40 mm aggregate to the BBM, bituminous that macadam road, so for BBM you are using at that time whatever 10 mm or 6 mm crust you are using with the bitumen, at that time that compacted proper, so that 40 mm is required. For WBM road, macadam मुरुम आणि मातीचा जो आपण त्यात दगड टाकून जो रोड बनवतो, WBM लेअर जो BBM च्या खाली असतो, so that for that 50 to 60 mm are required. So murum is there. Murum is compacted with the water with that. For that purpose, the various sizes of these aggregates are given for this particular construction. So here again, if you see, so same sketch is there. So various sizes are given. So these sizes are in mm. So this is again elongation. How elongation? किती लेंथ ला aggregate तुमचं जास्त आहे. Thickness is very is another part, and elongation, flaky is different part, and elongation is a different part. So how much elongate? लांब किती आहे? 20 mm thick आहे, but elongation is also affects the concrete workability. So again, you can see here the passing ISU sizes are given. So here for 40 to 50 mm is given, 25 to 40 mm is given. So if you see each and every, so last and elongation, thickness and elongation both given here. So for various conditions, we are using that particular aggregates into the concrete or BBM or WBM like this. So these sketches also you can see. Okay. So now again, so now how to test that flakiness and elongation, that we will see here. So flakiness index is the percentage by weight of the particle in it whose least dimensions is less than 3/5 of means of its mean dimensions. So flakiness index is the percentage by weight of particle in it whose least dimensions, that is thickness, is less than 3/5 of its mean dimensions. Then again, elongation is the percentage of weight of particle in it whose largest dimension. See, least dimension is the thickness and largest dimension is the length. So elongation, it means length. The aggregate chi length kiti hai. And the flakiness is nothing but the least dimension, that is thickness. How much thickness is there? So generally, we are calling 20 mm size aggregate. It means what? This is the thickness, flaky. If we see 10 mm size aggregate, it means that is the thickness. Then if we say 12.5 mm aggregate, it is again thickness. So these are the your thickness is nothing but the flakyness, and the elongation index is nothing but the length of your aggregate, and it is sorry it is greater than 1 and 4/5 times the mean dimensions. Then flaky and elongation particles may have adverse effect on the concrete, that is the bituminous mix. So that flaky and elongation particles have give the adverse effect on the concrete, that is the bituminous and on the bituminous mix. So flaky and elongation particles tends to lower the workability of concrete mix, which impair the long-term durability also. Again, if the bituminous mix is there, it means BBM layer is there on the road. So bituminous mix is there. So flaky particles are liable to break and disintegrates during the pavement rolling process. So how to test the flakiness and elongation index of the aggregate? So you can see here the test procedure for this particular flakiness and elongation. So if you see the quantity of aggregate shall be taken sufficient to provide the minimum number of 200 pieces of any fraction to be tested. So if we are performing the test of elongation and flakiness index, the quantity of aggregate shall be sufficient to provide the minimum number of 200 pieces. So 200 number of pieces we have to take for the testing, and the sample shall be sieved with the sieve specific in table number 1. So IS code for the aggregate 1489. So part 1 to part 7s are there. For aggregates, there IS 1489 is there, and for that various test we are conducting for that. Table 1 here for given is the for sieve size. Then separation of flaky material. Then in test procedure, what we have to do, separation of flaky material, each fraction shall be gauged in terms for the thickness on the metal gauge of the pattern shown in the figure 2 that we will see, or in the bulk on sieve having a elongated slot. So on this bulk having elongated slot is given also, and the width of the slot is used. The gauge or sieve shall be dimension specified in the column number 3 of the table, that appropriate size, that for the appropriate size of the material. So what given into the table that we will see here. So this table is given. If you see size of aggregate, that is thickness passing through ISU, retained on ISU, and thickness gauge and length gauge. So how much thickness is off and how much length of that particle that shown in that particular table. So we will move towards the table. Before that, we have to see this particular test procedure part. So the total amount of passing the gauge shall be weighted to the aggregate of this least 0.1 of the weight of the test sample. So 0.1% of the weight of the test sample is a weighted accuracy of that particular total amount of passing is there. So the flakiness index is the total weight of material passing the various thickness gauge or sieves, expressed as a percentage of total weight of sample gauge. And the separation of elongation material is each of the fraction shall be gauged individually for length and metal gauge of the pattern shown in the figure number 4, and we have seen that figures also. And the gauge length shall be specified in the column 4 of table number 1 for the appropriate size of material. So here again, the total amount of retained by the by the length gauge shall be weighted to the accuracy of the 0.1% of the weight of the test sample. जेवढं टेस्ट सॅम्पलचं वेट आहे त्याच्या 0.1% of the total amount of retained of length gauge shall be weighted. And the elongation index is the total weight of material retained on the various length gauge expressed as a percentage of total weight of the sample gauge. So we are here with this table, and in this table they have given the size of aggregate passing through IS. So topmost sieve up we have to use, that is the 63. See, very important, the sieve sizes. So topmost sieve we have to use the for aggregate is a 63 mm size, and bottommost sieve we have to use for the sieve analysis, that is 10 mm. So below 10 mm, below 63 mm, 50 mm sieve size sieve is there, then 40 mm size sieve is there, 31.5, 25, 20, 16, 12.5, 10 mm. So these sieves we have to use for the sieve analysis or gradation of the aggregates. So if we see the aggregate which are passing from the 63 mm, some of the aggregate will be retained. If 100% pass from the 63, so some of amount of aggregate will retain from 50 mm. So some of amount will pass on 50, which will be retained from the 40. So likewise, passing 40 and retaining 25. Similar to that, passing 10 and retaining 6.3. So this we have to done for each aggregate size for distribution. Aggregateचं साईज तुम्हाला जर ठरवायचं असेल तर या सगळ्या सीव मधून तुम्हाला ते पास व्हायला पाहिजे. Then and then you can say this is the aggregate in this group or this size. Then thickness gauge, it means thickness of aggregate. So the 33.93 here, the 27. So this is the thickness gauge we have seen in the table. And then length gauge, it is elongation. This is the Flaky. This is the Flaky, and this is the elongation. So this is the table given in the IS code also. So now we have seen the bulk density of the aggregate, then moisture present in the aggregate, and then the elongation and flakiness of the aggregate. So now we will go the fourth ingredients of the concrete is the water. As we have discussed, what is concrete? Concrete is a mixture of cement, sand, aggregate, and water. So these are the four main ingredients of the concrete: cement, sand, aggregate, and water. So the last part of the ingredients of concrete is aggregate. Sorry, water. So the specification of water to be used for the concrete making. If we have to make the concrete, then you can use the water which is sewage water. गटर मधलं पाणी तुम्ही कॉन्क्रीट मिक्स करण्यासाठी वापरू शकता का? No, we cannot use the water which is from the which is a wastewater. We cannot use. So we have to use the water which is maybe potable, drinkable water सुद्धा आपण use करू शकतो. But some of the standards are given for that water also. So there may be how much pH value of that water is required, how much turbidity of that water is required, how much chloride content, how much sulfate content is also required in that water. That we have to study also. So some of the standard specifications are given for the water which we are mixing in the concrete. So that water having a specific their test we have to conduct, and that we can use for the construction of the civil engineering project also. So concrete is one of the most durable construction material, and cement is one of the most energy intensive structure material in the concrete. Okay, so then the principal consideration on the quantity of mixing of water are related to performance of the fresh as well as the harder state. जोपर्यंत आपण वॉटर मिक्स करत नाहीये कॉन्क्रीट मध्ये, तोपर्यंत ते काय मिक्सचर होऊ शकते का हो? इवन दो यू हॅव ऍड सिमेंट, सॅन्ड, ऍग्रिगेट इन ड्राय स्टेट, ड्राय कंडिशन मध्ये सिमेंट, सॅन्ड, ऍग्रिगेट तुम्ही ऍड केलं, पण ते कॉन्क्रीट कधी होणार आहे? हार्डन कधी होणार आहे ते कॉन्क्रीट? सेट कधी होणार आहे? इवन दो यू आर नॉट युजिंग वॉटर इन टू दॅट concrete. Are you getting? So the water is also playing very very important role. असं समजू नका की सिमेंट न स्ट्रेंथ येते, पाणीच ऍड नाही केलं तर सिमेंट आणि ऍग्रिगेट सॅन्डला काय व्हॅल्यू आहे? Are you getting? So the water is a very very important place and role into the mixing of concrete. Why? Because if the concrete we have to give into the hardened stage, then the water is we have to add, and that water we have to add in the ratio of the water cement ratio. So we have to maintain that water cement ratio. Then the quality of water plays an important role in the preparation of concrete. Here written as we discuss also, the quality of water plays an important role. So we cannot add the wastewater into the concrete. Are you getting? Water ऍड करायचं तर तुम्ही म्हणाल वेस्ट वॉटर ऍड करू शकतो का कॉन्क्रीट मध्ये? नो. So some of these standards are given for the construction water. Construction water, it means in while making the concrete, you can use the water by using these conditions. There may be pH value should be in this range. So what is the pH value for potable water? Drinking साठी water आपण वापरतो, त्याची pH value ची range काय आहे? What is the range of for pH value for the drinking water? So this drinking water we can use for human being, but for the construction purpose, whatever water you are using, for that also some standards are there that we have to consider or maintain while mixing the water into the concrete. Then impurities of water may interfere with the setting of the cement, and they adversely affect the strength and durability. Whatever water we are using into the concrete that are not good quality, or some of the impurities are present into that water, there may be that water will affect on the setting time of the cement, that water will affect the strength of the concrete and the durability of the concrete. So very very important which water we are using, that is a without impurities. Okay. Okay, so again the chemical constituents present in the water may adversely participate in the chemical reactions, and thus the affects setting, hardening, and strength of development. So again, if we think about the chemical composition, some chemical constituents are present, into the water. Then also your reaction with the cement that affects the setting times, and again hardening of the cement and the strength of the whole concrete will affects due to the chemical constituents present in the water also. Then again in the addition of this water, the health issue related to the safe handling such as such water must be considered. So if we add the water into the concrete, then the health issue related to safe handling of such water. So water is bad impurities, water is there. If we handle that water, that is also dangerous to the our health also, while mixing that water into the concrete also. Then the suitability of water can be identified from the fast service record or tested to performance limits such as setting time and compressive strength and durability test. See, setting time, compressive strength and durability. These three factors are very important if we add the water into the cement, and that impurities if the present into the water, and due to that the durability, compressive strength and setting time affects on these three parameters, which are very important related to concrete. Also, the limits are specified for the mixing the water into the concrete. So that are the such as the total alkalinities of this water is we have to find, then chloride and sulfate content that we have to know, then biological treatment also we should know, and how much percentage or how much pathogens, bacteria are present or germs are present, that we should know before use of the water for the construction. And that reduction are also ensure safely or safety in the handling of reclaimed water and saline water. So very important water plays in the role of the mixing the concrete. So these parameters, so the water is alkaline water, chloride, sulfate water, then biological treatment and pathogens are present in water, that we have to study before use the water for the construction. So the functions of water in the concrete. What are the functions of waters in the concrete? वो काय करते water concrete मध्ये? So the water serves the following purpose. So there are many purposes are there. So the purpose is the weight the surface of aggregate to develop the adhesion, because the cement paste adheres quickly and satisfactory to the wet surface of the aggregate than the dry surface. So the wet surface, जो dry surface असतो cement आणि aggregate आपण sand mix केलेला, so that surface will be the if we add the water into the concrete, that surface will be the wet, and wet it means the prepare the plastic mixture of these various ingredients and the impart workability to concrete, facilitate the placing into the desired position of water, and also the needed for the hydration of cementing material to set the harden during the period of curing. So the hardened state, when we observe if we add the water into the cement or aggregate, ज्यावेळी cement बरोबर तुमच्या water's mixing होते, then and then your concrete will be goes into the hardened stage. And if this concrete goes into the hardened state, then it will be set for the period of curing, and you will get the proper strength and proper durability for that particular concrete. Then again, the quality of water in the mix plays the vital role on the strength of the concrete, as I discussed. जर तुम्ही प्रॉपर वॉटर सिमेंट रेशियो मेंटेन करून वॉटर ऍड केलं, तर तेच वॉटर काय करते, सो सिमेंटला हार्डन स्टेज मध्ये घेऊन जाते, and hardened stage it means you will get the strength after the sum of the period of curing time, and your strength will be increases and durability of concrete also increases. For that, the water is plays very important role into the concrete. So, and the potable water as a mixing water. whatever potable water is as a mixing. Potable means which water we are using for the drinking also. The common specifications regarding quantity of mixing water is water should be fit for drinking. See, whatever water we are using, that water fit for drinking also. It means not we can use other, no, we cannot use the other water which we cannot drink. Such water should have the organic solids less than 1000 ppm and contains the leads to be solid quantity that 0.05% mass of the cement when water cement ratio is provided 0.5, resulting small effect of the strength. Such inorganic solids are there into the present in the water. Then generally we are providing the 0.5 cement ratio, water cement ratio, and that affects the strength also. So but some of the waters should are not potable, may be used in the making the concrete with any significant effect, and dark color or bad smell water may be used if they do not possess the uh, deleterious substances. So we cannot use the bad smell water or a dark color water for the construction, so that your sulfate, chloride and sulfate attack will be there on aggregates, cements, and which cement reinforcement also, which we are providing into the concrete also as a RCC structure. And the pH value of the water, even 9 is allowed if not taste blackish. So 9 pH value is also not allowed for the construction water. Then in coastal areas where the local water is saline and have no alternate source also, so the chloride concentration up to 10,000 ppm is even allowed for the drinking. So for drinking water we are allowing the 10,000 ppm, so that water we can use for the construction also. And this excessive amount of alkalis, carbonates and bicarbonates in the natural mineral water may cause the alkali silica reaction. So the water which we are using for the construction plays an important role for making the concrete. So we can say the whatever potable water is there, that we have to mix with the concrete. So this is the first unit we have covered. And first unit was on the basis of ingredients of concretes. So whatever we have learned into the concrete technology also, and that ingredients of concrete we have learned once again in this advanced concrete technology. Okay, so this is here end of the unit number 1. So we have covered the unit number 1. So from next lecture we will start the unit number 2. So we will stop here for today, and we will continue unit number 2 from the next lecture. So I will stop. Wait, I will take the attendance, and we will disconnect for this meeting.